Hello everybody, welcome back. Today we're finishing off 7.2. We looked at absolute value functions in the previous videos, and we looked at piecewise functions. Now we're going to just talk about invariant points briefly. So an invariant point is a point that remains unchanged when a transformation is applied to it. So determine the invariant points of y equals f of x and y equals in absolute value of x. So if the whole function is taking the absolute value, that means that the x-intercept of the original is the x-intercept of the corresponding absolute value function, and therefore is the invariant point. Okay, so let's take a look at this. And I'm going to graph these two just so you can see a visual here. Alright, so we have the 2x plus 4, was it? 2x plus 4, and then the absolute value. Y equals the absolute value of 2x plus 4. Alright, so at that point is one of the points that remains unchanged, right? Okay? And so the interval of invariant points, so it's going to be the x-intercept plus all of the other points along this positive part of the curve, right? These are all the same. So the original curve is the red underneath. You can't see it now, but I'll take this out, right? Gone, to put it back in. Oh, sorry. Y equals absolute value. Now remember, don't blink, and there we go, right? So there it is, and there it is, right? So what points remain unchanged? So it's an interval of points. It's all the points of here. Okay. So all you do is find the, I'm not going to do this every time, but all you do is find the x-intercept, so you let y equals 0, right? So that would give you, again, I'm not going to do this for every function, but I'll just do an example. So we have 0 is equal to 2x plus 4, right? Subtract the 4 to both sides, right? We get negative 4 equals to x, and then divide both sides by 2, and we get x equal to negative 2, right? And that's where I showed you on the graph where it started, obviously, right? Again, I expect that you can do that pretty quickly. Again, just look at the graph. The graph gives you lots of information. So it starts here, and then it's all the values here. So the invariant point, or the interval of invariant points, it starts at negative 2 and 0, right? So it starts at negative 2 and 0. And then it continues on to the right. Okay? Yeah, so the invariant points will start at, like I said, at this x-intercept, and as you can see from the graph, they continue on along here. Okay? So the next one, again, I'm not solving all of these. So here you can clearly see that the x-intercept is 3 and 0, I would think. Right? Just solving quickly. So the x-intercept is 3 and 0. Alright. Okay. So what we'll do is we'll graph this quickly. So it's negative 3x plus 9. Alright. So we'll put the absolute value of negative 3x plus 9. Alright. So it's all the ones prior to that, right? To the left side of that x-intercept. So all the x values to the left. Okay? Alright, so I'm just showing you where it starts here. Alright. The next one we have difference of squares. So we have x squared minus 1. And here we do the absolute value of that same function. So we'll put the absolute value in, and there we are. Okay? Alright. So the absolute value. So what has changed is the original. Okay? So the interval of all the points in between, right? So remember, you take that away. Okay? All the points that have remained the same are all the x values less than negative 1 and there. So that's how you obtain those. We say, right here, all points to the right of that is, right? Okay. And here it's a little different. This one here is all points to the left, as you can see from your graph, right? And this one here is a little differently, like we just saw in our graph. So it's we figured out that it was going to be -1. Oh, -1, 0, and 1 and 0. So those are your x and y intercepts, right? So it's all points to the left of that, and obviously it was all points to the right of 1 and 0. Okay? All right, just look at that graph again, right? So the overlap, basically it's the overlap of the two functions, right? There it is, there it is, they don't change. Okay? Next one, let's put it in our graph, so minus x squared minus x, and then we just take that whole function and take the absolute value of it. Alright, so remember, there's the original function, and then we take the absolute value of the second function. What has remained the same? It's just the interval between these 2 points here. Okay? So let's deal this. All points between 0, 0. Right? Oh, sorry about that. 0 and 0. And 1 and 0. Right? Because, oh, there they are, right? So if you take that away for a second, take the blue graph away for a sec, go from here to here, and then once we put in the second function as the absolute value, the overlap is what we're looking for, right? Or all the invariant points. Okay? So all points between them. Alright? And the last one there, it's in vertex form. Let's do that one as well. So we have minus bracket x minus 4 squared, or 4 plus 4. Plus 4 squared plus 9. Okay. We'll just spread this out a bit. Let's get rid of that old function there for a second. There's the original function, right? See what overlaps it. Alright, so again, it's this part here, right? It's 7 and -1, -7, -1, so we put that in, right? So you'll see that this is the part that overlaps. So again, what that's going to look like is it's going to be all points between, and let's go back to the graph, -7 and 0, -1 and 0. Okay? And that's what's called invariant points. So there's some questions that have to do with piecewise function invariant points from 9 to 14. Alright, so that's it. In the next video we're going to be looking at absolute value equations. We're going to do a little bit of solving. Okay? And if you have any questions, please let me know. We'll be looking at these again in class. Alright folks, thanks very much. We'll talk again soon when we do 7.3.